Today's video will demonstrate how the assignment operator works for the vector class. Hello, I'm James Helfrich. It may seem silly to make a video about how the assignment operator works. You just copy elements over. It turns out, however, the assignment operator reveals a great deal about the design philosophy of the standard template library and even C++ in general. You see, C++ was designed with one thing in mind only: performance. Try to get as much computing done with the smallest amount of CPU cycles and the smallest amount of memory. And nowhere is this more apparent than in the standard template library. Here, the standard template library goes through extreme lengths to try to minimize the amount of work that needs to happen so that the assignment operator works. And this video will demonstrate exactly how that happens. The assignment operator has four cases. Case 1 is when the left-hand side and the right-hand side have the same number of elements. Notice how we use LHS for left-hand side and RHS for right-hand side, which if you think about it is kind of a silly name because there's no hands in sight, but nevertheless, that's the standard we use. Case 2 is when the left-hand side is bigger than the right-hand side. Case 3 is when the right-hand side is bigger than the left-hand side, but we have extra capacity. And finally, case 4 is when the left-hand side is smaller, but we do not yet have extra capacity. Let's take a look at each of these cases in turn. So let's take a look at case 1. The left-hand side equals the right-hand side. So my right-hand side is going to have 3 elements in it, and my left-hand side is also going to have 3 elements in it. And when I do the assignment operator, my pseudocode looks like this. I'm going to iterate through the elements. It doesn't matter if I use the size of the left-hand side or the right-hand side because they're the same. And I'm going to copy the elements over one at a time. Then I'm going to iterate by 1, copy, iterate by 1, and copy. And when I'm finished, the left-hand side has the same elements as the right-hand side. Now, case 2, the left-hand side is bigger. Okay, so my right-hand side is going to have 3 elements. My left-hand side is going to have 5. And when I do the assignment operator, my pseudocode is going to be quite different. First, I'm going to iterate through all the elements in the right-hand side, and I'm going to copy them over. So I'm going to copy the 77 over, then I'll copy the 88 over, and then I'll copy the 99 over. And what do I do with the rest? Now, the easiest thing to do is simply change the num capacity member variable of the vector so that I forget about the last 2 elements. But we want to do something different here. We actually want to call the destructor on those last 2 elements, so they're destroyed. Now, in C++, we can use new, which both reserves the memory and calls the constructor, and then we can use delete, which both deletes the memory and calls the destructor. Now, if we use a custom allocator, we can separate those actions. What I want to do here is I want to call the destructor on 44 and 55 without actually freeing the memory. So when I call destroy here, so case 3, the right-hand side has greater capacity than the left-hand side. So we'll start with the right-hand side having 3 elements and the left-hand side having 1 element. Now, when I call reserve, I'm going to increase the capacity of the left-hand side without actually changing the size. This will happen by first allocating a new buffer, in this case of size 4, then moving the elements from the old to the new, and then delete the old buffer. Now I have a size of 1 and a capacity of 4. Now, when I call the assignment operator, my pseudocode is going to look quite different. So first, I'm going to copy all the elements from the right-hand side to the left-hand side, as long as that element is still allocated in the left-hand side. So this will only go once. Now 77 will come over. This will be the assignment operator. Now I have to not only copy the 88 over, but I also have to call the constructor on that element. Because remember, I've only called the constructor on 1 element in the left-hand side, and that's in slot 0. I've not called the constructor in slot 1, 2, or 3. So therefore, I'm going to call the allocator's copy constructor, which will then call the constructor with the value 88, and then call the constructor with the value 99. Now, when I'm finished, I'm going to have a size of 3 and a capacity of 4, which means only 3 elements have had the constructor called, and the 4th element had not. Okay, the last case is case 4. In this case, with the right-hand side is bigger, but I have no extra capacity. So my right-hand side is going to have 3 elements. My left-hand side will have 1. When I call the assignment operator, my pseudocode is going to look quite different. On the surface, it may seem very straightforward. All I have to do is call reserve and then allocate a new buffer. But we don't want to call reserve because that will actually copy the 11 over from the old buffer to the new. And that copying is not necessary because we're just going to replace it with 77. So therefore, pseudocode is going to look quite different. So first of all, I'm going to allocate a new buffer. And then I'm going to call the constructor on every element from the right-hand side. So I'm going to call 77, then I'm going to call 88, then I'm going to call 99. Okay, now all element has been constructed and all the elements have been copied, but the left-hand side still only has one capacity and one size. Now what I need to do is I need to call the destructor on the old left-hand side buffer. And clear will do that. It will call the destructor on all the elements that happen to be in there. And then I need to deallocate, which means free the memory. And then finally, I got to assign the new buffer into the original location. Now we can learn more about the assignment operator for vector, as well as how reserve and resize and all the other memory allocation methods work for a vector, as well as how the allocators work in the C++ data structures textbook.